Okay, hello there. So these questions that I said yesterday, I think some people got a bit confused with them. I'm going to go through some of them, and hopefully you'll be able to complete this today then. Okay, so the first one says, Rebecca went on a bike ride. This graph shows Rebecca's distance from home on her bike ride. Okay, so I'll scroll down. So on the vertical axis on the left, it's the distance from home. So here would be home, and then that would be going away from home. And this is the time. When she started was 0 minutes, and then she came back here. Okay, so the questions then are, how far had Rebecca traveled after 30 minutes? So you look at the time, 30 minutes, that meets the line graph here. So it was 6 kilometers. Okay, the first one would be 6 kilometers. Okay, I'll write that in for you. So 6 km. The second question, after 60 minutes, Rebecca stopped for a rest. How long did she stop for? Okay, so go to the time, 60 minutes. You can see she stopped because she didn't go any further or she didn't come back. So she stopped. And she stopped from here to here. So if you go down, if you can figure out, these are going up in tens. Okay, so that'd be 70, 80, 90. So that means she stopped for 2 lots of those. So that's 20 minutes. 20 minutes. Just a quick stop. 20 minutes. And then the last one, how far did Rebecca travel in total? Okay, some people had different answers to this. It says in total, she traveled 12 kilometers to get there and then took a rest. And then she came back. So it's actually 24. So 12 there and 12 back is 24. That answer would be 24 km. Okay. I'll go through the next one and then I'll flick through a few of the last ones. So Jess drove from Leeds to Liverpool. She stopped at a service station for 30 minutes on the way. Which of these distance time graphs would represent Jess's journey? So that means she went to another place. So she didn't return home. She went from Leeds to Liverpool. So you could rule out some graphs straight away. So it wouldn't be A, because that's returning back. It wouldn't be C, that's returning back. B means you're coming from somewhere and coming back home, or coming back to Leeds. And then, yeah, so you needed one where there was a stop in the middle. Okay, so it could be D. Yeah, the only one it could be is D. That means she stopped in the middle. She didn't, the time moved, but her distance didn't move. So she must have stopped and then traveled on further then. Okay, the D. We'll do this last one. So Bill is a taxi driver. Use this graph to find the cost of a taxi for different distances. So here on the vertical is the cost of the journey, and this is the miles. So you can see here, it doesn't start at 0 automatically for the cost. That would mean there's a minimum charge just to get into the taxi, just to sit in the taxi. You can see that minimum charge must be £5. So it's £5 standard anyway. And then the further distance you go, the more that's going to cost. So yeah, so the fixed charge is £5. Part B, Bill makes 2 journeys. The distance of one journey is 10 miles further than the other journey. Work out the difference between the 2 journey costs. Okay, so you could pick any 2 parts on it. You could pick 10 to 20. That's 10 miles of a difference, and its cost goes from £20 up to 35, so that's £15 of a difference. Okay, you can continue with all those questions. There are 7 of them there, but that's 3 of them done. This one you had to continue on and see what it would look like if this continued on at a consistent rate. Okay, so try those ones, and then there is other graph questions for an extension. Good luck with it.